Hello everyone. Welcome to the Highway Survey and Design class. For many people, cambers are unfamiliar because in our daily lives, we observe with our naked eyes that highways are generally flat in the cross-sectional direction, making it hard to believe that there is a certain camber to the road surface. Imagine if the road were flat, how would we drain rainwater when it rains? The water flows to the lowest point is an age-old principle. Without a lower point, how would the water flow and drain? Therefore, on straight road sections, you will see drainage systems on both sides of the road. This is because the road surface is designed with a slight arch sloping from the center to the sides, and its main function is to quickly remove rainwater from the road surface. But is the larger the camber, the better? If it's too large, the safety and stability of driving on the road cannot be guaranteed, especially on rainy days when a water film forms on the road surface. If the camber gradient is too large, the wheels will skid and tilt. Such a road design that does not prioritize safety first and life first does not meet the requirements. Therefore, camber gradient is generally around 2 to 3%. It's worth noting that in areas with heavy rainfall and snowmelt on freeways and first-class highways, higher values for cambers should be used to ensure rapid drainage. For divided subgrade, each lane should have a bidirectional camber with a high center and low sides. There are various types of cambers, generally divided into three categories: parabolic camber, composite camber, and two straight-line camber. There are different choices for different materials and road surface grades. The parabolic type is flat in the center and steep on the sides. The disadvantage is that vehicles tend to concentrate on the flatter center, which can cause damage to the road center. The straight-to-curve transition type has a relatively gentle gradient compared to the parabolic type and is suitable for flexible roads with a width exceeding 20 meters. Due to the gentle gradient, its drainage efficiency is not as good as the parabolic type. Two straight-line cambers are mainly used for multi-lane cement concrete, that is, a rigid road surface with high hardness that is not easily shaped into a curve, ultimately forming two straight lines with a high center and low sides. From a drainage perspective, cambers should be larger, but from a driving safety and stability perspective, they should not be too large. In general, the cross slope of the shoulder should be 1 to 2% greater than that of the road surface. Different road surfaces have different requirements for camber gradients, which can be obtained by consulting the specification. It is worth noting that for 6-lane, 8-lane freeways, and 6-lane first-class highways, when the camber gradient on the super elevation section is too gentle, two cambers can be installed. When the longitudinal slope of the road exceeds 5%, the camber cross slope of cement concrete road surfaces and asphalt road surfaces should be less than or equal to 1%. The outward sloping cross slope of the hard shoulder should be the same as the cross slope of the travel lane. And for soft shoulders, the cross slope should be increased by 1 to 2% compared to the road surface, following the requirements in the table. After the above explanation, do you understand why the road is shaped like a camber? Do you know the reasons now? That is the content of this lesson. Thank you all.